basic mathematics. How are you, everybody who is watching this program? My name is Olenjolai, TAYAI single. Simply just call me Olenjolai. I'm very happy to have you. I would like to take this opportunity to welcome you to receive good news that will impact your life, in academics, and especially for ordinary secondary education. I thank God by His own grace, He called me to be a national teacher of basic mathematics, Form 2, Form 1, Form 3, and Form 4. So I would like to welcome you. So I will be teaching you, and here I am as a teacher, and you can there you are, you might be also a teacher or you might be a student. So whatever the case, whatever of your status, this is the good moment for us to exchange, and this is the good time for me to transform you from one point to another point. So you have to stay focused. Whether you're a national, international students, you're warmly welcome. Whether you're national or international guardians or parents, or just guardians or parents or sponsor who is just taking care of your sons and daughters who are in ordinary secondary education, this is the good opportunity for them to receive good news about the beauty of basic mathematics, which actually that it's a common problem, critical problems that encountered by ordinary secondary students in any class of the learning process. And even Tanzanians, we used to have a slogan that Isabati ni ugonjwa wa taifa in Swahili, that's the Swahili language, means mathematics, it's a national disease. And I want to tell you that mathematics is the best approach of solving the national critical complexity problems. So it's vice versa. We are going to reverse that phrase. It's not mathematics. It's not it means that the national disease, but it's a national solution. It's a solution for so many problems in human life. I'm a Tanzanian. I'll be using the syllabus and curriculums of Tanzania. However, that this content will benefit all the ordinary secondary students or intermediate school students across the world in any continent. So this is the national flag. We are very happy to have you. Firstly, I would like to welcome you into one of our online institutions, one of our online schools that called it Tanzania Online Ordinary Secondary School in square bracket Olenjolai. Again, how do we share these contents? How we can access everything? We can access all our contents that we are creating in form of the video of learning the beauty of basic mathematics, physics, and chemistry. We'd like to welcome you into one of our official YouTube channel for ordinary secondary school, or we call it in abbreviations O-Level. Our official YouTube channel is called Tanzania Online O-Level Secondary School in square bracket Olenjolai. This is a platform. It's a national platform. It's an international platform that the contents we are creating can be accessed at any time and anywhere. Have the goodness, there's no any physical limitations. You can access in vacation, you can access during the learning periods. And I would like to dedicate this program, and dedicate is just why am I doing these programs? In order to have students who are in Form 1, Form 2, Form 3, Form 4, QT students, private students, who like to enjoy the beauty of basic mathematics in physics and chemistry and biology for the rest of their year life. So that's the main objective. So if you are among them, that you feel from your heart that you would like to be an engineer, you like to be a doctor of medicine, you like to be a pharmacist, you like to be for example, yes, you like to be a great economist in the world. You like to be just a statisticians. So I would like to ask you that pay attention, and this will make Tanzania Online O-Level Secondary School your home place for learning and enjoying the beauty of the critical and complex issues which will be presented in a very simplified language. What are we doing? The vision, remember, we remind you the vision. We are teaching you, we have an assignment to teach and incubate ordinary secondary students by using different approach, different teaching aids, different methodologies, and different teaching style, so that we can have faster, intermediate, and slow learners simultaneously, because we are teaching also simultaneously. So we can have all those three levels of learners. And I'm here just to teach you what I know. I don't know everything about basic mathematics. I know small portions of it, but I would like to ask you to take advantage. Possibly what I know might be 100% of what you need for you to cross the border, to cross the next exam of the Form 2. So if you're international students, stay tuned. I'll be using English in Form 2, in all the trainings, in all the subjects of Form 2, Form 3, and Form 4. So if you're international students, stay tuned and enjoy the contents that we are going to prepare for you. So we are here to teach you how you can think differently. We are here to teach you how you can think outside the box, outside of the class. So so we are in departments of what? We're in departments of basic mathematics, the subject basic mathematics. This content is for the Form 2 or QT students or reciters who are reciting reciters. So here we have S. Okay, reciters. Okay, and this is chapter 1. That's in basic mathematics called the exponents and radicals. And this is session 8. We have taught you session 0 to session 7, and you can access in our official YouTube channel every session that you've missed if this is your first session. Okay, so the session is called the applications of exponents. Means that we have already covered in session 1 to session 7. We have already covered the big picture and every concept that you have to understand as a Form 2 students of exponents. So we have to see now where we can apply the concepts of exponents that I've been teaching you in previous sessions. That's what we are going to focus. But before I take you there, I would like just to give you some few instructions on how you can register yourself into TOOSO. TOOSO, it's abbreviations of what? Tanzania Online Ordinary Secondary School in square bracket Olenjolai. So if you don't have an email, please, I ask you to create or open a new email. Okay, a new email. It can be either a Yahoo email or a Gmail, right? That's the first stage. The second stage, if you have an email, then skip the first stage. Go to the second stage, where that you have to sign in in the YouTube, okay, by using your email, okay, by using your email. Then the third stage, after you sign in, we ask you now you can search TOOSO, but don't search TOOSO because it's not there. There we have Tanzania. T stand for Tanzania, O stand for online, O stand for O level, S stand for sec, second S stand for school, and O stand for Olenjolai. So if you want to search, just write, copy and paste this sentence or this name, Tanzania online O level sec school in square bracket Olenjolai. Why are we focusing on O level? Because all the contents, we have a vision of creating more than 600 teaching and training videos from the Form 1 to Form 4 basic mathematics, physics, and chemistry. So, and those contents will be they'll be special for O level students, for ordinary secondary students. You will never find any contents of advanced secondary students in this channel. You will never find any contents for ordinary diploma in this session, in this channel. You'll never find any contents that we are creating also for undergraduate students. It means undergraduate level. You'll never find them because we are teaching 4 levels by God's grace, not by our own power. Okay, so search TOOSO in YouTube. You have to search it in YouTube. So write Tanzania Online O level sec school in square bracket Olenjolai. Then you see a round buttons with the national flag. So it's a round buttons where at its center there is a national flag. So click it. Once you click, you will see a horizontal toolbar where it is written home, and then video, and the other text is playlisting, another is channel, another is community, and the last one is about. So I will tell you the functions or the applications of this horizontal toolbar. The first step now, we ask you now, because we want you to register yourself permanently and free of charge, no any registration fee. If you want to register into our official YouTube channel, then no any registration fee. So click these buttons of subscribe. Once you click it, it changes its text from subscribe into subscribing, and then the icon of the bell appear. Once this icon of the bell appear, click it once. You see 3 options. Choose the options of all. From there, you'll get notifications of any new session of exponential and radicals, because today we are going to cover everything about exponential, and then in the session 9 I'll teach about radicals. So when that session 9 is made public, you'll get notifications at any time and anywhere when you are online. So the YouTube community will be responsible to give you notification, but if and only if you have subscribed into our channel, and you will be informed in any video that we are going to make it public, right? So make sure that you do it for your benefits, because in this way you will make sure that it means that you will see or it will activate you, and it will give you updates about what you have to expect. Okay. The first step, we ask you, so after you have clicked that, you have subscribed, then we ask you that again to click. We would like to give you the instructions, the right instructions to minimize your time of searching. Playlist. Okay, click this to this texting or this software buttons that's called playlist, and we'll see so many playlists, because every chapter we create a playlist for every chapter. We create a playlist for every subject. We create a playlist for, so just chapter and subject. So we have a playlist for basic mathematics form 2. We have a playlist for exponents and radicals. So in the playlist, so for the case, for you to get all the videos about the exponents, so you have to search exponents and what? And radicals. So search the playlist which reads exponents and radicals. You will see the collections of session 1 to session 8, the coming one, the one that you are watching right now, session 9, up to maybe session 15. So you will see the collections, and the lectures or the sessions have been arranged sequentially. So that's very important. We believe that you are going to enjoy our content, so you would like to share. So share. So we ask you that you can click the icons of share. So to share, so you can share video link. So you can share video link, okay, as a students across the country of Tanzania, via social media. So any social media can be used to share these contents. For example, Facebook, for example, WhatsApp, for example, Twitter, for example, Telegram, Instagram, email. You can send the link of this video to your friends by using the email. So after doing that, I believe that you are ready right now to get good news about session 8. I'll give you some other announcement later on. Basically, in session 7, we've been dealing with the concept that's called the division, negative integrals exponents. So negative integrals exponents. So let me do the quick review. Quick review of session 7. So basically it is titled as what? Negative. So this is titled as a negative integral exponent. Negative integral exponents. So negative integrals exponents. So how do we experience this challenge? For example, if you have 8 power 3 over 8 power 5, so by using the division, the law of division, these two exponents have the same base, which is 8. So it will be 8 power 3 minus 5. So 3 minus 5, that's make negative 2. So this is 8 power negative 2. In other words, if you remember the laws of exponents, also this is equal to 1. If you reciprocate, it's 1 over 8 power 2. So that's what you call negative exponent. So we've been dealing with it in different aspects, okay, different aspects, and we did some examples, and I left the homework for you. So you can find that, for instance, again, you can find in the situation that maybe you have the video questions of x over x power 11. So this is x power 1. Simply, this is x power 1 minus 11. So the response is x power negative 10. So that's what we've been doing, and that's what we've been dealing with. So today, let us learn, or let me teach you about 1 applications of 40 applications of exponents. 1 application of exponents. Okay? 1 applications of 40 of exponents. Okay? So let us go together. The laws of exponents are usually used when solving questions that involve. So we say that the laws, I taught you more than 7, almost about 7 laws of what the laws of exponents. Okay, the laws of exponents are used in solving a problem, or in solving what? Equation, mathematical equation. Okay, mathematical equation or equations involving what? Involving exponents. Involving exponents. So these laws are used in that aspects. Okay? Okay, so the laws of what of exponents are used in solving mathematical equations involving what? Exponents. So we say that the following rules have to be employed in solving equation involving what? Involving exponents. So what are these rules? Are the question. Okay? The rules are this. The first rule, we say that if the bases are the same, then exponents must be equal for the 2 numbers to be equal. If the bases of what? Of exponents are the same in 2 sides, both sides means are the same, then we say that then the exponents must be equal for the 2 numbers to be equal. Then the exponent must be equal. The exponents must be the exponents must be equal. What does it mean? For example, on the left-hand side, we have exponents of base m power a, and this one is equal to base of m power b. So according to the laws of exponent, we say that m and m cancel. So a is equal to b. So exponents, these are the base, but in other ways, just to rewrite like this one, m power a, this is equal to m power b, and this implies that a is equal to b. So you have to remember, but this is given if m is not equal to 0. If m is equal to 0, then that is another condition. That's the first law that you have to remember. The second one, again, this is common one. Most students they used to remember. But another secondly rule that, or laws of exponents that have to be remembered by the mathematician whenever you are solving equations involving exponents. And this is a statement. If the exponents, remember these are the exponents, if the exponents of the two exponents are the same, then compare or equate equated the year, compare with the year basis. So say if the exponents of the two exponents are the same, then compare or equate the year basis. Okay? So please, you can pause the video and then copy those 6 steps for your permanent registrations or your lifetime registrations in Tanzania Online or Level Circuit School. Square bracket Olenjolai. Okay. So I believe you've finished the copy. You can pause the video and copy so that we may break down or we may learn together the concept of this session. That is all about applications of what of exponents. Do you enjoy the beauty of exponents? Tell me in the comment section, please. Do you understand what am I teaching? Tell me in the comment sections, please. So I say that this is in case we have m power a, and then so on the left hand side we have n power a. So here, in this case, exponents are the same. A is equal to a, but m is not equal to n, right? So for this case, we say that we cancel the exponents and then we equate the basis of the two exponents. So m is equal to n, and then we find that on the left hand side we have a variable x. On the right hand side we have maybe a natural number or a counting number, right? So that's the process that we're expecting. Okay. Sometimes we have. Let me just go to with the 30 laws. Sometimes you can find that we have a power m, then times b power n. But on this side, you'll also find a power, let's say, power x, and then times b power. So this I would like just to expand your knowledge or your understanding of laws of exponents. So in this case, in other words, so the base of these two exponents is not the same. The base of these two exponents is not the same. But the base of these exponents and these exponents is the same. And the base of these exponents and this exponent is the same. So because the base are the same, so we can deduce this one. A power m, this is equal to a power x. Right? So it means that what we said. So for that case, we say fine. So a and a cancel. So m is equal to x. And we find a particular value. Again, we might say that we have what? B power m. And then say what? B power 1. Same base, then equate to exponents. So n is equal to 1. And then you solve the problem. So these are the 3 laws that we are going to use them step to step as long as we continue with this concept, right? So let us go into example. So in previous session, that's session 7, we ended in example 28. So ladies and gentlemen, this is example 29, which is very simple and you have to remember. And I want to tell you that in this session, which is session 8 of applications of exponents, I'll be solving 3 sample questions from the NECTA Form 2 exam, from the national exams of Form 2 in Tanzania. That has been done in previous years. I will solve 3 questions from 3 past papers to encourage you, to show you how questions are being asked, to give you confidence that right now you can even solve some questions in Form 2 NECTA exam. Okay? We didn't finish the first chapter, but you are confident enough. Okay? So example 29. Find the value of n. Find the value of n, given that Roman A 2 power n is the simplest. Always I begin with simplest example, then I go to challenging example. Then B, we have 4 power 2n minus n is equal to 16. So you have to find the value of n. the questions is like that. So you never be given more information that here you have that life exponent. No, but you have to examine the given questions. Remember these 3 laws of exponents because they simplify your life as well as possible. So, ladies and gentlemen, you can pause the video and try to solve that questions yourself and to test whether you have understood what are the concepts that I've been teaching you, right? Please stop the video and try to do that example 29 on the rough paper. And then once you are done, then you can come back and do together, right? Try it, try it, try it. Thank you very much for trying. Okay. So solution. So this is 2 power n plus 1. This is equal to what? This is equal to 64, right? So what the base of this exponent? So remember that. So the first stage for you to understand, okay, the given what? Given base of the exponents is what? Okay, or not? On the left hand side is, so suppose that this is equation 1. Okay, on left hand side is what? Is 2. So express what? Express the natural number. Express 64 as what? Okay, in base what? In base 2, in order to compare what? To compare the exponents. So 64, if you want to express in base 2, this will be 2 times 2, 8 times 2, 16 times 2, 32 times 2, 64. So how many? 2, 6, 2. So it means that 64, ladies and gentlemen, is equal to 2 power 6, right? So this is what? Equation 2. So it means that we go for the second stage. The second stage, we say that substitute equation 2 in what? In equation 1. So substitute equation 2 on the left hand side, you have 2 power n plus 1. This is our exponent. This is equal to 2 power 6, right? So same base, cancel the base, equate the exponent. Same base. So remember that these are same base, and that base is same base of what? Of 2. So cancel, then we say n plus 1 is equal to 6. So make n the subject. So it means that we have n plus 1 minus 1 is equal to 6 minus 1. So this will be 6 minus 1 is what? 5. So therefore, the value, because we've been asked to find the value, so the value of what? Of n is what? Is 5. So the value of n is 5. That's the final response for 1a. You see? Simple, right? If you have succeeded to get the same answer when you have been trying in the rough paper, let me clap your hands for you. Congratulations. Soon you'll be a great mathematician of our age. Okay. So ladies and gentlemen, right now let me do Roman B. Ladies and gentlemen, let me do Roman B. So Roman B, we have been given what? Exponents of base of 4. So 4 power 2n minus 2. Oh, no, 2n minus n. So this is our exponent, this is base. And then so on the left hand, on the right hand side, we'll be given a number. You have to follow the same procedures, right? So the first step. So you can call this one equation 1. Okay? So equation 1. So you say that, check the base. So you say the base of left hand side is what? Is 4. Then express what? Express 16 in base of 4. How? So 16 is a how? Is it divisible by 4? Yeah. So you can divide by 4, then you find that 4 times 4 is equal to 16. In exponential form, this will make 4 power 2. So suppose that this is equation 1, equation 2. So you go for the second step. And the second step, we say that substitute equation 2 into equation 1. So if you do that, then you find that 4 power 2n minus n, 4 power 2n minus n This is equal to 4 power 2. So same base, compare the exponent. So 2n minus n is equal to 2. So 2n minus n is equal to what? Is n. N is equal to what? To 2. So therefore, value of n is 2. Got that? Okay. So let us do example 30, which is kind of trick question. If you join me, you're warmly welcome. I'm teaching about applications of exponents as one of the concepts that we have to cover in exponents at the first topic of Form 2. So, ladies and gentlemen, join me in solving example 30, and you can pause the video and try this example, solve example 30 yourself, and then you check the solution. So, example 30, so in example, okay, so you say that solve for B. Solve for B, given that, solve for B, given that Roman A, B power 3 is equal to 27. Then Roman B plus 1 power what? B plus 1 power 3 is equal to 64. You have to listen carefully because later on I will give you the homework. So you have these two questions, Roman A, Roman B, solve for B. So the unknown is B. But at B, we can find it by using laws of exponents, the 3 laws of exponents, and just you have to use, for that case, you have to use the first law of exponents, not the second law of exponents. Okay, so solution. So in previous example, which we examined or we expected the nature of the exponents, and we found that the simplest way, if we compare or if we make the base of the exponents on left hand side to be the same with the base of the exponents on right hand side. So also even Roman A we have to examine. Okay, so Roman A we have to examine B power 3 is equal to 27. So this is equation 1. Okay, B power 3 is equal to 27. That's question 1. Wonderful. So what's the simplest way? So the simplest way, we have to express what is 27. So we have to examine. So the first stage, okay, so the exponent, so here the base is B, it's unknown. We cannot express 27 as in base of B, but we can express 27 in exponent of 3. So this is kind of concept because it's really challenging and teach you to think differently. Okay, so the first step, we say that the base, no, the exponent of left hand side in equation 1 is 3. Then let us express what? 27 in exponents of what? In exponents of 3. How? So this is the process. 27. What are the factors of 27? 3 is a one factor of 27, and 9 is another factor of 27. There's 2 and 27 itself. There are 3 factors. 3, 9, and the 27 itself. So it means that I can get 27 by taking 3, then 3, then 3. So this in exponential form, it's 3 power 3. Beautiful. So we have exponents of 3. So it means that we say that 27 is equal to 3 power 3, and this is equation 2. So now, so we have the same exponents. So the next state, which is the second state, means that we ask you that to substitute equation 2 in what? In equation 1. So if you do that, you have B power 3, and this is equal to 3 power 3. So same exponent, cancel. Same exponent, ladies and gentlemen, cancel. Then compare the base. So B is equal to 3. Therefore, the value The value of B is 3. You're done for Roman A. Roman B, so this is the technique. If the variable, if a known variable is given in part of exponents, then you have to compare bases. And if the variable, if the unknown variable, for example, x or a or b or m, is given in the part of base, then you have to compare the exponents. So you have to apply the first law, the first general law of exponents and the second general law of exponents. Wonderful. This simplifies your life and you should not be stressed because of the equations involving or solving questions involving what the exponents. Wonderful. So let us go for Roman B. Or you can pause the video and try to solve it yourself. So you have b plus 1. I want my students to be confident enough. So that's why that I'm solving so many questions. You see right now, I'm still in the first subtopic of exponents. Okay? Exponents, radical, laws of exponents, just 2 subtopics, but I've already solved the set examples. My main objective is to make my students to be self-learning and to be self-confidence, but not overconfidence, just to have confidence within the contents that you have to cover. So, just you have to follow the 2 steps. So this is equation 1. So the first step, you know what the first step? Examine what? The exponent. So this is expressed in exponent, this is not expressed in exponent. So the base is, it contains a known variable, which is called the b, while the exponents is the rates known. So it means that we say that the exponents of what? Of the left-hand side of equation 1 is 3. So then express what? Express the natural number 64, which it's a value, okay, in what? So express 64 in what? In exponent of what? In exponent of 3. That's the process that you have to do. Ladies and gentlemen, we have to think, how can you express 64 in exponents of 3? That's the great and wonderful, okay? So to express in exponents of 3, you have to take 4 times 4, you get 16, times 4, you get 64. So this is equal to what? Is equal to 4 power 3. Then this is 64 is equal to what? 4 power 3, and this is equation 2. So you've already expressed this 64 as in exponents of 40 or 3. So you go for the second step. So now this is the simple process for you. So the second step, you say that substitute equation 2 in equation 1 above. Okay? So you have b plus 1 power 3. This is equal to what? 4 power 3. So compare the exponents. When you compare the exponents, you have b plus 1 is equal to what? Is equal to 4. Make b the subject. So b plus 1 minus 1 is equal to 4. We'll teach you to make the subject in part of radical. So 1 minus 1 is 0. B plus 0 it is b. B is equal to 4 minus 1. This is equal to what? B is equal to 3. B is equal to 3. So because b is equal to 3, therefore we conclude that the value of what? The value of b is 3. So these are the solved examples in the book of secondary basic mathematics, book 2, right? So these are the solved examples in page 13. So let us solve problems now. The problems that have been given, and then I'll leave the homework for you. And once I have finished to solve the problems, then I'll solve past papers or nectar from 2. Okay? Okay, so if you want to solve the problems of applications of exponents, then you have to come to this one, solving questions of what? Questions of exercise 1.1. Exercise 1.1e. 1.1a, and we'll be focusing on only one question. And this is question 8. Question 8 at the reference. And you have these contents and findings in page 14 of secondary, the book called Secondary Basic Mathematics, book 3. So before, let me put the, before I write out the questions, I have an announcement, very important announcement for you. The first announcement I would like to announce, I would like to inform you about the access of reference materials that you need for you to master basic mathematics in Form 2. Okay. So we have also Tanzania Online Ordinary Library, where we equip our students with reference books, which actually that can help them to master and enjoy these subjects more than they ever expected. So firstly, we have 2 reference books which I recommend, and I'll be using them to prepare you for the basic mathematics Form 2 exams, NECTA. The first one on the left-hand side is called Secondary Basic Mathematics Book 1, prepared by the Tanzania Institute of Education by following the syllabus of United Republic of Tanzania. And then the second one is called the Secondary Basic Mathematics Book 2, Tanzania Institute of Education. These are the sample books that you can access in Tanzania Online Ordinary Library. This is the online library. You can order this book in any region of Tanzania, and there is no need physical meeting between you and me, between teacher Olenjolai and you as a client or as a student. So how much does it cost? That's a very important question. This one costs 17,000 only shillings, while in the local shops you can get with the price of more than 20,000. And this also it costs 17,000 Tanzanian shillings. That is only the buying cost. I'm not doing business, I'm doing service. I'm servicing my students so that they have to make sure that they understand every concept that been written in this book, and they have to keep in their mind for the rest of their life. So in case they need the prerequisite concept, they should not worry about that, because Olenjolai has already written the informations of basic mathematics in Form 1, Form 2 in the mind of his students for the lifetime, right? So this costs 70,000 without the transport cost. So these 2 books, you can order them with the price of 34 Tanzania shillings. And then again, you have another one, which is called, this is Secondary Basic Mathematics Book 1 and Book 2, Mathematics for Secondary School, Form 1 and Form 2 Students Book by Oxford. So this also you can order it. So you have to check the price. But again, we have also mathematical figures. We'll be using mathematical figures when I'll be teaching you about the radicals. So Maximilian's for figure mathematical tables and formulas. So this is going to cost you have to order this mathematical table by the price of 4,000. Okay, so 4,000. And then this is, again, you need questions and answers books. This is Form 2 Mathematics Review, Problems and Solutions from 2003 to 2019. You can order this book. Also, this one is costing, Basic Mathematics Form 2 is costing 8,000. So this is only 8,000. You can order this book. And this is 4,000 mathematical table. So if that's the case, so we say that, okay, so this is, you can order this book because it compares questions from Form 2 exams because previously the Form 2 exams comprised 25 questions, but in the new examination format, the Form 2 exams of basic mathematics contains only 10 questions with section A and B, and some of them they used to have even section C. Right? It means that part A, part B, each question has 2 parts, part A and part B. Okay? So you can order this book. We are going to use, and even in session, you will see that I'm going to refer this book as how I do refer this book, Secondary Basic Mathematics, in all the sessions of the Form 2. So you can order the package. The shipping cost is the same if you order one book And it's the same if you order this package of the books. Please, I ask you to order this package of the books to have a department of mathematics or to have a library of mathematics in your home or in your bag when you are going to school. Do that. And then I want to tell you that you will never cry and you'll never complain and you'll never complaining about your decisions to be a student of Tokoso. So let us see now questions from that exercise or question 8. So let me write on the blackboard. So the question states that for me, in a sequence, this is example 31, and it's concept. It's concept because, okay, it's concept. So the questions have the same information. Solve the following question. Solve the following equation. Solve the following equation. Okay. The first one is 2 power n with n power x 2 power x plus 1, and this is equal to what? 2 power 5. Then we have b, this is x squared is equal to what? Is equal to 64. Then we have c. It's 1 over 3 at base power what? Power x. This is 81 for negative 1. Then this is Roman D. So Roman D, this is 288 is equal to 2x squared. So those are the 4 questions. For my students, actually this is a breakfast, isn't it? You can try. And let's just see for the few questions that you cannot solve them by using the brain. But most of the questions you can find the value of x by using the brain without even writing anything. Okay? So solution. So because I want you, so this one, I want you to do the homework for this. This is your homework. And then, okay, yeah. So that's lately. Okay, but I want to give you another homework. Yeah, this is your homework again. You try. Don't worry about that too. That too is very simple for you to eliminate. Solution. Roman A. So Roman A will be given 2 power x plus 1. I think that this one, yes, this one should be your homework. Let me solve this. It might be difficult for some students. So Roman A is homework. Roman B is very simple. It's homework. Very simple also. So let me do Roman C. Roman T, the base is fraction, which is 1 over 3 power x is equal to 81 or negative 1. So this is equation 1. Remember the principle I told you. If the variable is in exponent, make sure the base is the same. If the variable is in the base, make sure exponents are the same of left-hand side and right-hand side of equation. This is an equation. So it means that the variable is in exponent. So we have to make sure that we have the same base. So this is the first step. The first step, okay, apply what? Means that apply law of exponents. Law of exponents, which states that 1 over a is equal to a or negative 1. For that case, we have what? We have 1 over 3. According to that law, this is equal to 3 power negative 1. Right? So this is what? This is equation 2. So we have equation 2. Exponents and radicals is a very interesting topic for every student. So you go for the second step. We have simplified the base of 1 over 3. So we say that substitute equation 2 in what? In equation 1. So substitute, instead of 1 over 3, we are going to have 3 power negative 1, then power x is equal to 81 power negative 1. Right? So if we use the law of exponents also, means this is equal to 3 power negative x is equal to 81 power negative 1. So this is equation 3. The base is not the same, so you have to work again on the base of the right hand side. So we go for the steady state. The steady state, we say that express, so we say that if you examine, so we say that the base of left hand side of equation 3 is 3, then express what? Then express 81 in base of what? In base of 3. How? So this is the process. 81, the factors of 81 are 3, 9, 27, 27, 54, 54 plus 27 to be 70, yes, even 27. So simply say 81, usually it is 9 times 9, the simplest way. 9 times 9 from the table of 9 is 81. But again, we know that 9 times 9 is equal to 3. If you take 3 times 3, we get 9. Then if you take 3 times 3, we get 9. So this makes us 3 times 3, 9, and 3 times 7 times 3, it's 81. So express this expansion in exponential form. So 81 is equal to 3 power 4. 3 power 4. This will make what? Equation 4. So this will make equation 4. I want to prepare competent or excellent mathematicians who have a plan to score 100 marks in the Form 2 exam. That's my vision. Okay? But that will be not enough. Will just give me 50% of my joy, of my happiness, of my hard working. But the remaining 50% is in case you use this information and solve real life problems. I will be so happy. Okay? So we go for the first stage. The first stage, we say that substitute equation 4 in equation 3. Okay, equation 3. So 3 power negative x. This is equal to what? Is equal to 81. What is 81? The 3 power 4 power negative 1. So this is equal to what? This is equal to 3 power negative 4 if you expand. So right now the new equation is 3 power negative x is equal to 3 power negative 4. Same base, compare the exponents. So compare the exponents. So negative x is equal to negative 4 by rows of integers. Negative x over negative x is positive over negative 4 over negative 1 is equal to 1, is equal to positive 4. So the response x is equal to 4. So for Roman C, the value of x is 4. If you have tried before, you pause the video and tried on the rough paper and you got x is equal to 4, congratulations, right? Congratulations. Keep trying. Okay, so for Roman D, we'll be given 280 is equal to 2x squared. So the variable is in base, but this 2 is kind of giving you what? So it means simply say the first step, simplify question 1. Simplify question 1. To simplify question 1, you have 288, then you have 2x squared over 2 over 2. So this is 144 is equal to x squared. So this is question 2. So a known variable is in base, and then the exponent is what? Is 2. So the known value is in exponent. So we have to make sure that we express the exponent. We express 144 in exponent of 2. That according to the laws of exponent. Second step. So we say that the exponent of what? Of the right hand side, which is x, is 2. Then let us work hard. Let us express 144 in exponent. An exponent of what? Of 2. Exponents of 2. So mean that on the left hand side we have 144 an exponent of 2. This according to the table of 12. So 12 times 12 is equal to 144. So 12 times 12, this will make 12 square. 12 square. So this will make equation what? Equation 3. So if that's the case, you say that we go for the same step. We have to substitute. Equation 3 in equation 2. So if you substitute equation 3 in equation 2, you have 12 power 2 is equal to x squared. Same exponent, apply the second law of exponent that I told you. So same exponent, so we compare or we equate to the base. So 12 is equal to x, or in other way, x is equal to 12. So therefore, the value of x is what? Is 12. You're done. So I believe that from an A and B, it's a very beautiful, it's a very sweet breakfasting for my students. Make sure to do it and give me the feedback in the comment section. Do you enjoy the beauty of exponents? Tell me in the comment sections, please. Do you understand it? Don't watch and leave. I want the feedback. I'm teaching an M-Tech class. So please give me the feedback by using the comment sections of this video, whether you understand or you don't understand, so I can improve the methods and techniques. However, that I believe 99% that all my students who are watching this program right now, they do understand what I'm teaching them, and even they understand more than they expected, because the heart of to also is understanding. Well, so then that was example. So we did example 29, we did example 30, we did example 31. So right now I want to take you example 32, which is come from the past paper. So example 32, you have to refer what? You have to refer nectar from 2. So national nectar, that is National Examination Council of Tanzania, right? Nectar from 2. Nectar from 2. Okay, of 2,000. The book that I asked you, you can order it for only 8,000 instead of 10,000. 10,000 in most of the local shop in Dar es Salaam. Okay, so this is one of the question in 2004. Yeah, questions in 2004. So nectar from 2004, and this is question 18. So one of the oldest past paper. So the question states directly like this: solve for n. Solve for n if you have what? The base is 3 over 5 power n minus 1. Then this is equal to what? 25 over 9. 25 over 9 power 2n. So at that time, if you solve this question, you have to be rewarded 4 marks. So these are the questions of applications of exponents. You have to solve for n. You have to solve for what? For n if that. So solution. You can pause the video. Every example, you can pause the video and try it yourself. Because you want to make these programs active learning. So you try the question, you become an active student, and become an excellent basic mathematics students for the rest of your life. Right? So solution. So we have been given 3 over 5 at the base power exponents of n minus 1. This is equal to 25 over 9. This is exponents of what? 2n. Okay? So the unknown is in exponent. So we have to make sure that the base is the same. That's the technique. Unknown, which is n, is in exponent part. Right? In exponent part. So you have to make sure that the base of the exponents of left-hand side is equal to the base of the exponents of right-hand side. So we apply the first law of exponents that I taught you in session 8, that we cancel the base and we equate the exponents, then we find the value of a known variable. Wonderful. That's all. That's the technique. I know that many students, they used to say that, oh, mathematics, it's a national disease. No. Mathematics is the best solution for the national real-life problems. Mathematics is not a problem. It's a solution. It depends how you interpret it or who is teaching you. So you say that, so this is the base. So the base of left-hand side, so the first step, if we insert the base of left-hand side of equation 1 is a fraction, is 3 over 5. Then let us express what? Let us express 25 over 9 as base of what? Base of what? 3 over 5. At the process. So here we go. So you have 25 over 9. So 25 over 9 itself, this is equal to 25. It's 5 times 5. And the 9 is 3 times 3. So ladies and gentlemen, in exponents, this is 5 square over 3 square. So I gain 25 over 9. This is 5 over 3. Same exponents, which is 2. So this one is equation 2. So once we have this, so we go for the second step. Second step, we say that substitute equation 2 in equation 1. So substitute equation 2 in equation 1. We have to substitute 25 over 9 is 5 over 3 or 2. Okay? But we didn't express. I think that's no. We have 5 over 9. Yeah. So we didn't express. We have to make sure that we change it. Huh? Okay, so I think that let us put there and then we'll see. Then we have what? 3 over 5 about our n minus 1. This is equal to what? 5 over 3 or 2. Then we formed exponents of 2n. So if you simplify, this is 3 over 5 power n minus 1. This is equal to what? 5 over 3. And the exponent is 2 times 2 is equal to 4n. Okay? So the base is not the same. 3 over 5 is not equal to 5 over 3. So you have to change one base into the other one. So because we have already recommended that you have to express this in this form, and this we formulate equation 3. So you have to say that, you have to recall the law of exponents. Which law of exponents? The law of exponents of what? Of negative interval. So the steady state. The steady state we call the law of exponent, which is a power negative. For example, a power negative what? Or we say that a over b. This is equal to what? A over b. This is equal to 1 over b over a. However, that in terms of exponents, you say that a power negative 1 is equal to 1 over a. That is. So a power negative 1 is equal to 1 over a. But in other languages, this is what we mean. This a over b power negative 1. Okay. So it means that we say that a power negative 1 is equal to what? 1 over what? 1 over a. Okay. So this is the law that I taught you in previous session. You have to remember that's what you have to apply. But remember that also 1 over a is equal to a power negative 1. So for instance, we have 5 over 3. 5 over 3 itself as base. This is equal to what? This is equal to 1. Okay. Okay, this is equal to 1 of what? 3 over 5. And it is true. Why? For example, if I take 1 divided by what? Divided by 3 over 5. This is equal to 1 over 1 times 5 over 3. So it's the same value. So even you use a calculator, 3 over 5 gives what? 0.6. 1 over 0.6 is equal to 5 over 3. Which is what? It's 1.66666. So simply, you have to understand that 5 over 3 in exponent is equal to 1 over 3 over 5. Remember this. Okay? So this will make equation 4, for example. But remember this law, right? So if you have 1 over a, this is equal to a power negative 1. What does it mean? So this means that this law, we have 1 over 3 over 5. This is equal to what? This is the base right now. 3 over 5 power what? Power negative 1. Power negative 1. So this is what? This makes what? Equation 4. So now we can take equation 4 and substitute in equation 3. It's a kind of a trick question. So we go for the third step. Third step or your third step. So the third step, we say that substitute equation 2, equation 4 in equation 3. So do such kind of a substitution. On left hand side, you have 3 over 5 power what? N minus 1. Then this is what? 3 over 5 power negative 1 power 4n. So multiply the exponent. 3 over 5, because it's the same base, n minus 1 is equal to 3 over 5 power negative 4n. So same base now. Apply the first law of exponents that I told you in this section. So if you apply it, then you find that the base cancel n minus 1 is equal to negative 4n. Right? So it means that we are solving for n. So if you are solving for n, we have n minus 1 is equal to negative 4n minus n. So n minus n is 0, we have negative 1, and this is negative 5n. So over negative 5 over negative 5. So n is equal to 1 over 5. That's the response. So therefore, n, the value of n is what? Is 1 over 5. And you can test 1 over 5 minus 1. And 1 over 5 power 4. It's negative 4 over 5. And that's negative 4 over 5. So the same one. Okay? So again, you have another example. So this makes what? 4 plus 8, so example 32. So we are going for example 34 right now. 33. Okay, so you have again example 34, which is from two NET exam of 2018. And I'll leave a homework for you. Example 29, 30, 31, 32, example 33. You have to refer NECTA, NECTA exam, NECTA from 2018, question 7 from 2018 or from the previous years or recently. The questions of exponents and radical in NECTA Form 2 exam is found as question number 7, either part A or part B, but sometimes there are some changes. So question 7A goes to 7B, which is about logarithm, and we are focusing in exponent right now. So the question states that use laws of exponents. Use laws of exponents to simplify. To simplify what? Simplify 2r cubic square over 2r power 3. That's the question. Solution. So use laws of exponents to simplify that expression. Very simple expression. I've taught you. Let us solve it. Okay, so the first step. Apply laws of exponents to simplify. And the first law of exponents that you are going to apply is if you have a power m times n, this is equal to a power m n. So in numerator, we have 2r cubic square of what? 2r cubic. So this is equal to what? So this is equal to 2 power 2 And hence you have what? R power 2 times 3 divided by what? 2 towards 2 power 3 and R power 3. So this will make what? So this will make 2 power 2 over 2 power 3. Then have R power 6 and have R power 3. So again, this will make what? So make 2, same place, subtract the exponent, so 2 minus 3, then you have what? R power 6 minus 3. So the law we are using is if you have A power M over A power N, this is equal to A power M minus N. So after simplifying, it's a very simple question compared even to what we did in example 32. So we say that our response we have 2 power negative 1 and also we have R power negative 3 because this 6 minus 3, yes, positive 3. So if you also, the third step, if you recall another law of A power negative 1 is equal to 1 over A, so then if you have 2 power negative 1, this is equal to 1 over 2. So mean that right now we have what? 2 R cubic square over what? Over 2 R cube. This is equal to what? Is equal to 2 power negative 1, which is 1 over 2. Then we multiply with what? We multiply with R cube. Simply this is R cube over 2. It is true. So therefore, 2 R cube square over 2 R cube. This is equal to what? R over 2. Okay. Let me give you the homework. And then end this section. So this is homework what? Homework 8. Plus the other homeworks that I have left, 2 questions. And this will make example 4. Far netta from 2 exam of 2019, question 7. Take your questions and answer book that I asked you, that I told you that you can order this book and use it during your studies of Form 1, Form 2, Form 3, and Form 4 by only 7,000, by only 8,000 Tanzania shillings. We can send it to you anywhere. So solve for n. Solve for n in the equation in the equation 16 3 power 16 power 3 minus n, then 2 1 plus n. This is equal to 1 over 2. Other question? Believe that you're going to solve it and enjoy it. Okay, again, ladies and gentlemen, I would like to say this is the end of session 8 of applications of exponents. It has been a very good time. I spent almost 80 to 81 minutes, 80 minutes. That is just the standard for the 2 sessions in Form 2 education. So I thank God who have called me, who have given me chief of teaching. I would like to say this is the end of session 8. I invite you in session 9 when I will introduce for you, or I will teach you the general introductions of the radicals and the concepts of the roots and everything about radicals, which kind are it's a new concept for you, but you have covered it during your primary education. So nothing will be, just the language will be changing from Swahili language into English language for those who have come from Swahili media. So thank you very much for joining me. May God bless you. I appreciate your participations. I believe that you're going to give me the feedback in the comment sections. I remind you to subscribe. I remind you again, if you feel from your heart that you want to offer God your free will Thanksgiving, you may offer it through the telephone number 0759745331, because God is the founder and sponsor of this program. But not every God, a living God, the God of Abraham's, Isaac, and Jacob, is the owner of this program. So please, again, subscribe, share the link of this video with other students. Be an active student. I ask you that to be an active student, and you have to join me online and use the internet to access our contents every day, because we are adding at least 1 video in a day. So until we meet in session 9, may God bless you and keep enjoying the beauty of basic mathematics for the Form 2. See you in the next session. This is Olenjolai from Tanzania.